Climate change is happening and will likely accelerate. It is being driven primarily by rising carbon dioxide emissions from the combustion of fossil fuels. Cities currently contain 1/2 of the world's population, contributing over 2/3 of the energy-related greenhouse gas emissions. This is projected to rise in the coming decades as urbanization trends intensify. Strategies to address climate change mitigation in cities are limited by our inability to quantitatively characterize where, when, and how greenhouse gases are emitted. Our response to this challenge is the Hestia project, a data model system that quantifies all carbon dioxide emitting processes in an urban domain down to the individual building and street level. We have completed this effort in the city of Indianapolis and are currently working on similar efforts in Los Angeles and Phoenix. The methods used to quantify the on-site fossil fuel carbon dioxide emissions combine a series of data sets and simulation tools such as a building energy simulation model, traffic data, power production reporting, and local air pollution reporting. Total annual carbon dioxide emissions have been categorized into commonly used economic sectors. Commercial emissions are laid out in a spoke and hub pattern. Residential emissions are laid out in surrounding subdivisions. Industrial emissions are large and placed along major transport arteries. There's one large international airport, a regional airport, and a heliport downtown. Vehicle emissions are restricted to minor arterials and larger. Electricity production is dominated by the large coal-burning power plant near the city center. The coal-burning power plant and the international airport are the two dominant emitting sources within the Indianapolis landscape. Hourly emissions show a more dynamic nature. Note that the commercial buildings have greater emissions during the daytime hours. Residential buildings, by contrast, have greater emissions during the nighttime hours. Vehicle emissions exhibit rush hours in the morning and in the evening. Here are all the sectors combined for night and day. Note the morning transition from the enhanced residential carbon dioxide emissions to the vehicle emissions, and then to the commercial and industrial emissions as the business day evolves. Finally, we present a sped-up day-night cycle for the winter, on the left, and the summer, on the right. Note how the winter building emissions are far greater than the summer equivalent, due to greater building heating demand. The Hestia system can be applied to any US city. The system can be used for verification and holds tremendous potential as a guide for managers and local organizations to create effective, economically efficient emissions reduction options.